Hi everyone. Today we are going to see about nanotechnology. So before getting the topic, we'll see what is nanotechnology. While many definitions for nanotechnology exist, the NNI calls it nanotechnology. Only if it involves all the following: research and technology development at atomic and molecular and macromolecular levels in the length scale of approximately 1 to 100 nanometer range. So between these range, we can call it as nanometer. Creating and using structures, devices, and systems that have novel properties and functions because they are small and intermediate size. Ability to control and manipulate atoms by using these steps. Next slide. Size spectrum of elemental particle. So in this slide explains how the nanometer size. Okay, as you can see that the hair having 100 micrometer. So compared to the hair, the nanometer is very small. The viruses, bacteria, and other contamination material available in nanoscales. So as you can see, this pollens have 10 to 100 micrometer, and then microfiltration and ultrafiltration and reverse osmosis. Okay, so these 1 to 0.1 to 100 nanometer, we can call it as a nanomaterials sizes and ranges. What are the materials of nanotech? Nanostructures. So there are different nanostructures are available. One is nanocrystals, quantum dots, and other nanoparticles, nanowires, and nanotubes. So these nanostructures are available different sizes. So first one, nanocrystal and quantum dots, insulators, semiconductors, metals, magnetic material. Likewise, other nanoparticles and the radius size is 1 to 100 nanometer, ceramic oxide, bulky balls. Nanowires, metals, semiconductors, oxides, sulfides, nitrates, and then nanotubes, carbon including multilayer materials. So these are the properties available for nanotechnology, and so electrical, magnetic, mechanical, optical, biological, so many properties are available. Each properties have different kind of solutions. Okay, so nanometals have unique properties like when the size is reduced, the properties will change. And then these properties, how can these properties used to protect the environment? And the next slide is categorizing nanomaterial. So here origin and chemical composition, aggregation state, surface modification, depression, and shape and structure. Okay, so the nanoparticle materials have different kind of categorizing. One is nanocapsules, ultrafine aerosols, nanoparticles, and quantum dots, nanotubes. And then applications of nanotechnology. So atomic industry and chemical industry, engineering, electronic industry and construction, medicine. So every field nanotechnology, they are making more components or more product using the nanotechnology. And then to continue to the applications of nanotechnology, textile industry and energy, in energy, fuel cells, solar cells, batteries and capacitors, they are making in nanometer sizes, and then cosmetic, food and drinks, household, and sports outdoor. Okay, we are at the beginning of a revolution in how things were made. Okay, and then where things are made and whether they are made. Okay, so these this is a revolution in nanotechnology. And then two scenarios for copying with the new revolution. Environmental impacts are an unintended consequences of technology development and regulation must be applied to reduce impact. And then environmental co-optimized part of technology and development and is a primary development. The challenges available in the nanotechnology: use nanotechnology research, help clean up past environmental damage, correct present environmental problems, prevent future environmental impacts, help sustain to planet for the future. So here some of the applications we are going to see about in nanotechnology. First one is sensors, improved monitoring and detection capability, better control information for the environmental protection and risk management, more efficient use of material, more data on waste, real-time and accurate sensing of many components simultaneously at extremely low concentration, frequently in hostile environments. Okay, so next application is treatment, cleaning up the waste stream of contamination, particularly those substances that are highly toxic, persistent within the environment, are difficult to treat. Promise for cost-effective, specific, and a rapid solution for treatment of contaminations. So next application is green manufacturing, atom by atom construction, less material to dispose of, two aspects. So use the nanotechnology, we are going to make a green manufacturing and then green energy. So nowadays the solar cells are made by the nanotechnology, particularly thin film technology is comes under the nanotechnology. And then implication of nano geochemistry, knowledge of formation at atmospheric aerosols and the movement of natural nanoparticles in air and soil can help inform the solution to man-made problems. Implication toxicity, essential to risk analysis for ecosystem and human health. Implication, fate, transport, transformation, determine the exposure route for both natural organisms in a variety of ecosystem for humans in the environment. Okay. Likewise, implication exposure, bioavailability, bioaccumulation, and industry ecology